I'm going to be talking about failure analysis in heterogeneously integrated systems. This is a talk that was put together by Dr. Ed Cole, who's a fellow at Sandia, and he's disappointed that he wasn't able to join us this week. He asked me to step in for him, so sorry you don't get Ed. The good news is I got to pack a suit, so sometimes plans change. Let's start with why would we talk about failure analysis? We've been hearing a lot about design and development. And so what's the purpose of failure analysis in a microsystem? We do failure analysis today to ensure reliability and yield, make sure that our product will meet its mission requirements over its designed lifetime. And there's lots of effort in failure analysis across state-of-the-art integrated circuit manufacturing. We have techniques for a variety of different integrated circuit technologies, from silicon to photonics, and a variety of different techniques that we deploy, whether it's electron beams or ion beams, light, thermal measurements. So what's the issue when it comes to a 3D system? Well, primarily, it's about being able to get to the specific point where you're trying to do the failure analysis assessment. So it's defect accessibility that's the problem. When you have a stacked system, you have interfaces that are underneath other parts of that system, and you can't get to where you think the defect is to be able to do the measurement you want to do. So what can we do about this? Well, we certainly don't want to stop doing the things that have made us successful in planar systems. So there's a whole set of things you can do from an integrated package for testing purposes, such as using JTAG and using our available failure analysis tools when they can work to get at the defect location. But there's probably three major areas to think about a little bit differently in terms of needed developments. So the first one I'll call take apart, meaning disassemble portions of the system. The next we'll call listen. This is like sense something about the potential defect. And the last is to both stimulate and listen, meaning apply some stimulus and then detect a response. Of course, you can imagine a combination of these might constitute a fourth category. So the goal here is to maintain the integrity of the defect. You don't want to add ambiguity in your measurement, but you do want to be able to do the failure analysis task at hand. So let's talk about a couple of examples. From left to right, an example of take apart might be use a wafer dicing or coring tool slightly differently to be able to take a dielet off of an interposer. Not what the tool is designed for, but perhaps it would be useful in doing that take apart step. Next might be to listen. So in the middle is an example of an optical thermomechanical platform that would be able to focus on specific places where maybe there's an interconnect issue that's creating some heat and help isolate that problem. And the goal here is to be able to do that much more quickly than you would be able to with existing tooling. Finally, you can imagine doing something to cause a change in behavior of the defect to make it more easy to detect. So this is stimulate and listen. The example here is an X-ray source that hopefully will be able to change the behavior of, say, a specific transistor to help you isolate that that's where the issue is coming from. So these examples are ways that we might approach the problem of failure analysis in 3D systems. Of course, this presentation isn't the first body of thought on this topic. There are roadmaps from IEEE and EDFIS that are looking at these kinds of considerations. The intent here was really to give a simplified perspective on where necessary research is, where we need to be pushing the boundaries in order to be effectively prepared for a 3D world. There are ongoing research efforts across all three of these particular approaches, with the primary goal of being able to identify where defects are without adding that ambiguity into measurement. So to close, I would like to thank the PIs at Sandia that are working on the three examples that I showed. Their names are there. And then the efforts that this portfolio are part of are managed by myself and Erica Douglas as well as Ed Cole. Thank you.